Hello students, in this video we'll see how to solve a constant coefficient differential equation when there's a combination of two impulse functions as a forcing function on the right hand side. So let's consider the initial value problem. Y double prime minus y equals delta t minus 2 plus delta t minus 4. With the initial conditions, y of 0 is 0 and y prime of 0 is 0. We can notice that since there's no initial displacement and no initial velocity, we don't expect any dynamics to happen until the time t equals 2 when there's an impulse of one order, and then at time 4 there'll be another impulse. So we solve this problem by taking the Laplace transform. So take the Laplace transform. And this will give us s squared y tilde of s minus s y0 minus y prime of 0. That's my second derivative term. Minus y tilde of s is equal to e to the negative 2s from this delta function and e to the negative 4s from this delta function. At this point, we can plug in our initial conditions that both y of 0 and y prime of 0 are 0, and this allows me to factor the equation. So to factor my equation, I have s squared minus 1 applied to y tilde of s is equal to e to the negative 2s plus e to the negative 4s. Solving, I can conclude that y tilde of s is e to the negative 2s over s squared minus 1 plus e to the negative 4s over s squared minus 1. And now at this point we make the observation that 1 over s squared minus 1 inverse Laplace transforms to the sinh of t. And I can use that in conjunction with our shifting rule to see that y tilde, so if we inverse transform y tilde, we will get 0 if t is less than the shift of 2, and then we will get sinh of t minus 2 if t is bigger than or equal to 2. The second term will inverse transform to 0 if t is less than 4, or sinh of t minus 4 if t is bigger than or equal to 4. Now we can break this up even further. We can say that our final solution will be 0 if t is less than 2. Between 2 and 4, I will just have the sinh of t minus 2, and this is the range between 2 and 4. And between 4 and infinity, we'll have both the sinh of t minus 2 and the sinh of t minus 4. So I have the sinh of t minus 2 plus the sinh of t minus 4. And this is in the range when t is bigger than or equal to 4. And it's possible to use some hyperbolic trigonometric identities to simplify these expressions even further, but for us this is a sufficient answer. Again, we note that before time t equals 2, the initial displacement and velocity imply that there's no dynamics. Once we get to the point t equals 2, this force will kick in and give us this behavior for all time. And once we get to the point t equals 4, this force will kick in and we'll get the additional sinh of t minus 4 impacting the dynamics. So, to conclude, whenever we have delta functions on the right-hand side of an initial value problem, we will Laplace transform and together use the shifting rules to write down the final solution bit by bit. Thank you very much.